All right, guys, welcome to PreCal. This is 2.2.5, and we're going to be doing horizontal expansions and contractions of sinusoidal functions today. So I had you guys take a look at 107. Try that out on your own. Feel free to use Desmos to help you out. And then once you have finished it, come up here and we will go over that. All right, so let's take a look at these. So there we go. All right, so our base graph here of sine, and then if I graph sine of 2x, I get this, right? So I now have two full cycles where I had one cycle for the original, okay? And then my period from here until here, that's the length of pi. All right, cool. Then let's take a look at sine of 3x. So here I have 1, 2, 3 cycles finished in one base cycle, right? And my period now is, if I zoom in, it should pop up, there we go, is 2 pi over 3. Awesome. So I have 3 cycles, period of 2 pi over 3. Hopefully I'm starting to see some connections between both the period and the number of cycles and that number. So how about 0.5? If I do 0.5, well, I only see half of that graph in this base period. So the other half is way over here. So it takes me all the way until 4 pi to get that full period. So let's talk about what we can hopefully see. So we're trying to find two things here. We're trying to find how many cycles are in the base period of 2 pi. And then secondly, what is the new period going to be? So for 2x, I had 2 cycles. For 3x, I had 3 cycles. For 0.5x, I had 0.5 cycles. Hopefully that one's pretty easy, right? So this b parameter which we have is going to always be the number of cycles in our base 2 pi period. Right? So we can then use that and say, well, how is that going to tell us what the period is? Well, here my period is pi. I want you to also remember that 2 pi over 2 is equivalent to pi. Then for 3 it was 2 pi over 3. And then for 0.5 it was 4, which 4 is the same as 2 pi divided by a half, because if you divide by half you multiply by 2, right? So hopefully that's a little bit harder to see, but it should make sense, right? If I were to graph the sine of 4x, without looking at it first, what should we see here, right? We should see 4 cycles between 0 and 2 pi, and then the period length, well, 2 pi divided by 4 would be pi over 2. So I should see, so I should see 1 full cycle to pi over 2. Lo and behold, that's what happens. So our prediction's right. Now we have our general rule for what that b value is going to do for us. So let's hop back over here and try the next part. Okay, so I want you guys to go ahead and do 108 through 111 on your own. You shouldn't be too bad now that we have that rule. So try those out and then come back here and we will go over those together. All right, now that we're back. So we have our graph of 2 sine of x minus 1, and we want to say, what is this graph going to do to it, right? So it should be the exact same graph, right? But our period is now going to be 2 pi over 3 as opposed to 2 pi. So it's still going to be moved down 1, have an amplitude of 2, but now it'll be a lot shorter of a period in there, right? So if we graph both of those at the same time, let me just turn off all these graphs. So our first one was 2 sine of x minus 1, and then 2 sine of 3x minus 1, right? So if I zoom out a little bit, that's what I'm seeing, right? Here was my base period, right? But now I have 1, 2, 3 of those in that base period. Okay. So it's doing what we predicted. Awesome. It means we're on the right track here. So then let's take a look at 109. So we want to sketch a graph of each of these labeled the key points. And as you graph, try and think about the method. So I'm going to do these on Desmos just to make it a little bit faster and a way for you to like check. But I'm also going to try and talk about, hey, here's what we should be seeing on all of these. So our first one, so you can see this here. All right. So our first graph is 2 sine of 4x plus 5. I put a space in there. So it's up there. That's the problem. Oh, okay. So what I should see here, right? This should be shifted up 5, has an amplitude of 2. So I'm going to have my midline through 5, and I should go up to 7 and down to 3. And then this 4 is going to cause me to have 4 cycles in my base period. So I'm going to have 1 full cycle every pi over 2. So I do that. Here we go. I'm seeing that pi over 2, pi over 2, pi over 2, pi over 2. There's 4 full cycles in my 1 base cycle there. So exactly what I predicted. So my key points there for 1 cycle end up being 0 and pi over 2. So then for this, that's halfway between 0 and pi over 2, so that's pi over 4. Then this is halfway between 0 and pi over 4, or pi over 8. And then over here, between pi over 2 and pi over 4, we're going to be down here at 3 pi over 8, because we had 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8 for our kind of key points there. And then that cycle continues for the rest of it. All right, the next one that we're looking at is 5 times the cosine of x over 3 minus 10. So this one's a little bit different. Okay, so let's talk about what we know right off the bat. The amplitude is going to be 5. Awesome. We're also shifted down 10, so we should see it way down here, centered at 10. But my amplitude's 5, so it should go all the way up to -5 and down to -15. Right? Okay. And then this x over 3. If I rewrite this as 1/3 x, it's the same thing, right? So we can think of it as that b value being 1/3, if that helps. So if I take 2 pi and divide it by 1/3, that's multiplying by 3. So I should have a period of 6 pi, right? So let's go ahead and graph that and see if that's what I get. Well, here we go. It's cosine here to here. It's 6 pi. That's my period. Awesome. So if I were to graph this, point there, halfway between those is 3 pi. Halfway between 0 and 3 pi is 3 pi over 2. And then halfway between 3 pi and 6 pi is 4.5 pi. So we'd be right there. Okay. So what if we want to graph the next one? So we got 3 sine of pi over 2x. Okay. So let's think about this. All right. So this one, I have no vertical shifts. Okay. My amplitude 3, so I should be midline at 0 up to 3 down to -3. And then my b was pi over 2. So what's that going to do? If I follow my pattern, right, it means that I'm fitting pi over 2 cycles in 1 2 pi period, which is a really hard thing to kind of visualize. But what you're going to notice is when you find the period, that's what makes this one really nice, right? So if I have 2 pi and I divide by pi over 2, those pi's cancel. So I really just have 2 over 1/2, which is going to be 4. So what I should see, if I change my units here, let's step by ones, I should have a period of 4. And lo and behold, that's what I get, right? At the midline, goes up to 3, down to -3, and it has a period of 4. So then halfway there is 1, and then halfway here is 1. Sorry, halfway there is 2, halfway between these is 1, halfway between these is 3 for our kind of key points for that one cycle. So that's pretty cool. Let's try it out with 4 cosine of 2 pi over 7 x minus 1. Okay, so if I do 2 pi over 7, right, 2 pi divided by 2 pi over 7, the 2 pi's cancel, so I have 1 over 1/7. So multiply by the reciprocal, and I should just have a period of 7. So I should see a cycle from 0 to 7. I'm shifted down 1, so I should be down here as my midline, and then I have an amplitude of 4. So that should go from -1 up to +3, and then down to -5. So here we are. Here's our, sorry, it's cosine, so it'll start here. So it starts here, goes down, and bottoms out at -5, and goes back up. My full cycle is at 7. So we're seeing those. And then again, once I have those, it's halfway between those for those kind of key points there and there. All right, awesome. Let's hop back over to this. So on 110, we're trying to match these up, so we can go through these fairly quickly. And if we look at a cosine of 3x, well, that's a base cosine, but it's going to have a much shorter period, and the period would be 2 pi over 3. So if I look here, there, so my cosines always start at a peak. So it'd be here, down to here. There's 1, 2, 3 periods in one base period. There's going to be my A, the second one. For B, I got 2 times the sine, so my amplitude's 2, and it got shifted down 1. So it should go up to +1, down to -3, up to +1, down to -3, starting at -1. There's one full cycle there. There it is. It's that fourth one. See, it's a cosine of 2x plus 1, so I'm up 1. So I should have a bottom out on the x-axis and a top out at 2. And it's cosine, so it'll start at the peak, and it'll have 2 full cycles and 1 2 pi period. Looks like this one right here. D, sine of 1/2 x. So that 1/2 is going to actually make my period extra long, so I should only see half of a period in the 0 to 2 pi region. Standard sine curve, it's going to be this very first one here. Right? And then on E, that minus pi over 4 is going to be the standard sine curve, but shifted to the right, pi over 4. So looking for that. Not here. Looks like here, right? So standard sine curve, up to 1, down to -1, and my shift is over here, halfway between 0 and pi over 2. So that's going to be my last one. Then cosine of x minus 2, so that's the standard cosine graph, but shifted down 2. So I should see it kind of peaking at -1 and down at -3. So I'm looking right here. It looks like that one. Awesome. And then G, -2 times the sine of 2x. So it's an amplitude of 2. That 2 on the x is going to make it have 2 full cycles in one base period. And then it'll be starting off by going down as opposed to going up because it is negative. So looking for that, looks like the one right over here. I start off by going down, and I got 1, 2 full cycles in that one base period. Then my last one, 2 times the cosine of x plus pi. So that's a cosine curve. Amplitude's now 2, and it has been shifted to the left pi, so I should see that peak at -pi. So peak at negative pi, and then my amplitude is 2. So up at 2, down negative 2, it's going to be that one right there. Awesome. Okay, last one here, number 111. Okay, so this is, we're trying to model a yo-yo here. So what do we know about the yo-yo? Its lowest point is 5 inches above the ground. The string length is 30 inches, and it takes 2.5 seconds to return to the same position. So that's a lot of really important information for us. So first of all, why is the maximum point of our yo-yo here at 35 inches when the string is only 30? Well, that's because we're holding it at 35 inches above the ground, because we don't want it to actually hit the ground. So we have our from the low point to the high point, that's 30, but since we're going to be up higher, that's why it's at 35. So what's the amplitude of this function? Well, if it's 30 from the bottom to the top, our amplitude is half of that, or 15. Our vertical shift, well, we're going to be, if it's 35 to the top, right, so, or sorry, it's 5 to here, right, to the bottom. Our amplitude is 15, so 5 plus 15. We're going to have our midline here at 20. Okay, so that's our vertical shift. I keep using the term midline. That's what we're going to end up calling this imaginary line right through the middle of these functions. So spoilers, that's what it's called. Okay, so we had in Rule 7, we said that if we take the take 2 pi and divide it by that b value, we got the period. Now they're going to say, hey, how about this equation where the period times the b value is 2 pi? Well, if we just take both sides here and divide by b, we get p equals 2 pi over b, and that's what we've been doing. So that's kind of where that comes from. So let's talk about how we could find the b value from here, because here we know the period, because it says it takes 2.5 seconds to return. So from top down and back up, that's a length of 2.5 seconds. So if my period is 2.5, I can plug in 2.5 here and then divide 2 pi by 2.5, and I would get 2.5. 2.5 is 5 halves. 5 halves, 2 divided by 5 halves is multiplying to get 4/5, 4 pi over 5 as my b, right? And then the graph can be represented without using horizontal shifts. Which trigonometric functions should we use on that basis? So if we don't want to do shifts, right, and we're starting off at a bottom point, we're going to want to use cosine, but we need to make it negative, right? Because if we were doing shifts, then we'd have to do a like sine shift of this much, or just do a cosine where it starts here and make it negative so it starts on the bottom, not on the top there. Okay, so now let's try and write an equation that'll model this. So if we go back over to Desmos, let's try and put together all the stuff we just went over. So we said we're going to use negative cosine. Okay, I then want my shift to be up 20. Okay, because I needed it to be moved up to that midline at 20. My amplitude was 15, so I need a 15 in front of it there. And then I didn't want any shifts, but left and right. But I did want this to be what was it, 4 pi over 5. Let's see if this matches what we're looking for. Let's change this so I can see just one cycle. So they're going 0 to 40 on the y. And they're going 0 to 6 on the x. This should be what we're wanting to like see. So here to here, it's a distance of 2.5. Has that, has all of those cycles. Awesome, we got it. So hop back over here. Determine the first 4 times when your yo-yo is 25 inches above the ground. So on this, when I'm 25 inches above the ground, I'm on this line here. So that's here, and here, and here, and here, and here, and so forth. So to find those, it's a little bit difficult, but on graphing calculator, really, really easy. Just let's us graph y equals 25 and look for those intersections. There, 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 and there. So at time 0.76, time 1.74, time 3.26, and time 4.24, that's when my yo-yo is exactly 25 inches above the ground. Okay. All right. Now let's head back over here and go over some notes real quick. So the 5-point method, this is kind of an example of how we can graph these. I've gone over this, not in this exact wording, but if we find, if effectively peak, 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 and then those 2 midpoints there, then we have all the stuff we really need. Or if it's a sign, then we can go the intersection with the midline here, here, and here, and then peak and peak, and there's those 5 things. Once you have those 5 important parts, you have enough of your cycle to get a good sketch of it, and then just copy and paste that for all the rest of that, going left and right as far as you need. So again, read through that, but if you feel pretty confident, it shouldn't be all that bad for us. All right, so go ahead and try and recap to yourself how you would graph a sine u subtle function using that like method, putting those points in, stuff like that. And then homework wise, here we go, 113 through 120, and that is it for 225. I'll talk to you guys next time.